The next topic in statistical process control is called process capability. Okay, your textbook doesn't cover this topic, but this is an important topic, so I thought I will include it. The process capability refers to a process that is already in control, okay, whether the variability in that process, which is in control, is small enough to be capable of meeting the specification of our customers. Okay, so you have to distinguish between the concept of process being in control and process being capable. These are two different concepts. You shouldn't mix these two things up. So for us to start studying whether a process is capable or not, we have to first make sure that the process is in control. The natural variation of a process should be small enough. So that means there are only natural variations. There is no other variation present in the process. So first step is to see whether the process is in control or not. Make sure that it is in control. So there is only natural variation. Okay. Then you see whether the natural variation is small enough to meet the standard required. Okay, so if it is, then the process is said to be in control, and there are three levels of meeting the standard. So there is this basic level, and then there is the next level, and then there is the next level. We'll talk about that in just a second. So process capability is a measure of the relationship between the natural variation and the design specifications. Okay, is the natural variation small enough to meet the design specifications? So we have two different numbers that we compute. Okay, actually this is the one that measures whether the process is capable or not. So there is this process capability index. So that's called C sub pk. Okay. Now, so we have the middle part. Okay, so that's your target value, and then you have two limits: upper specification limit and lower specification limit. So this is what causes confusion. So these are specification limits as opposed to control limits. So we have the mid part, which is X double bar, and then we have the upper control limit and the lower control limit. That's in the control chart. But here we have the middle line, so that is the target for the specification. That's different from X double bar. So now we are talking about specification, right? So the mid part is the target. So for example, if a bottle is supposed to have 16 ounces of cola, then 16 is your middle level. And then if you have a tolerance limit, so like it can go up or down by 0.2 ounces, then the lower specification limit is 15.8, okay, 0.2 ounces, and upper specification limit is 16.2 ounces. All right. Now the X bar is the actual process average. The process average may be 16.01 or something. Okay. Then upper specification limit minus X bar divided by 3 sigma, then X bar minus lower specification limit divided by 3 sigma. So 3 sigma here is this 99.7% limit. Okay. And the smaller of these two gives us the index called C sub pk. Okay. Now for our purposes, let's assume that X bar is smack in the middle of the target, but you have 3 sigma from the production process gives us, suppose if the process variability is such that it is exactly same as the specification. So which means you get 1 here. Okay. So that means with 99.7% variability, you'll be within the specification limits. There is only 0.03% that you're outside the limit. So if C sub pk is 1, then you're meeting the specification at the 3 sigma level. Okay, because 3 sigma variation fits in with your specification. Okay, but usually in practice that is not considered capable. A capable process must have at least 1.0, but usually 1 and 1/3. Okay, so 1 and 1/3 is required. That means at that level, if you require 1 and 1/3 for C sub pk, what that means is, okay, even if it is 4 sigma, suppose if the denominator, instead of dividing by 3 sigma, if you divide it by 4 sigma, you will get 1. So that means your production process sigma is so small that if you go from the midpoint 4 sigma up and 4 sigma down, it will still fit into the specification limits. So usually a good production process will have a C sub pk index of 1 and 1/3, not 1. Okay, 1 means you're barely meeting it. Okay, 1 and 1/3 is the minimum level that is required, which means even 4 standard deviation will fit into the process specification. Now, on the other hand, if you require a C sub pk of 2, that would mean that 6 standard deviations will fit into the specification. Even if you go, instead of 3 sigma or 4 sigma, if you go 6 sigma up and 6 sigma down, the sigma is so small that even that 6 sigma interval is really small and it will fit into the specification limits. So C sub pk of 1 means your 3 sigma limit will fit into the specification, which is mediocre. If C sub pk is 1 and 1/3, then 4 sigma range will fit into the specification limit. That is the minimum standard people normally require. But if your sigma is so small that if C sub pk is 2, then 6 sigma range will fit into your specification. That's the gold standard.